This one is 2.10. Here there is a pin jointed cantilever truss shown. All the members have the same cross section area A and elastic modulus is E. There is a point load applied here at R. We need to figure out all the forces here in all the members, and we need to find out the vertical deflection of the loaded joint, which is R here. Okay, so what we can do here is we can start analyzing these joints one by one. On joint R there are only two members there, so we can analyze this first. So let's call this FQR and this one as FRS. So if I write equations for joint R, we can write down FQR plus FRS divided by square root 2, because this angle is going to be 45 degree because both the lengths are same. This is in X, and in Y we can write FRS over square root 2 plus W equals to 0. So from this we can calculate FQR equals to W and FRS equals to minus W square root 2. Now we have solved for this one, we have solved for this one. So the next joint we can move to is this right here, because this will again have only two unknowns, this one and this one. So let's call this FQS and FST. So we can write down the equations for joint S, equations, and I have missed one force, which is going to be this way, which is your FRS. So if I write the equations in X direction, we have FRS square root 2 because of the angle 45 degree there, minus FST equals to 0. This is the X force balance. Similarly in the Y direction, we can write FQS plus FRS divided by square root 2 equals to 0. So from this we get the next two forces, which is your FST equals to minus W and FQS equals to W. So now this is also known, this is also known. Now we can go to joint Q. So we go here. Now this is known, this is known, so we have only two unknowns again there. So this one is FPQ, this is FQT, this one is FQS, and this one is FQR. So for joint Q we can write equations, joint Q, and your equations will be FQR positive minus FPQ negative minus FQT divided by square root 2 equals to 0, because this angle is also 45. In the Y direction we will have FQT divided by square root 2 plus FQS equals to 0. So if I solve these two, I get the value of FPQ equals to 2W and FQT equals to minus W square root 2. So now we have picked up all the member forces. So part A, this is over. Now the next part, we need to find out the vertical deflection. So for vertical deflection, we can use the Castigliano's theorem, which says your deflection in the direction of applied force is the derivative of your potential energy with respect to the applied force W in this case. So we know this. This can be written as the member force times derivative of member force with respect to applied force times the stiffness, which is L over EA for member IG. So for each member we can multiply these three entities, and that cumulative sum is going to give us the total deformation. So for this purpose it's a good way if we can make a simple table, and we can list out all the members here. We can have PQ, we have QR, QS, QT, RS, and ST. Now in these members we have calculated the forces. So your member force in PQ right here, we have calculated 2W, and QR, which is right here, W. So these two are 2W and W. Similarly, your QS is right here, which is W, and QT minus W over square root 2. So W minus W over square root 2. Similarly, RS and ST, they are minus W square root 2 and minus W. The second part is your derivative. So Fij with respect to W. So the derivative of this with respect to W is 2. This is 1. This is 1. Minus square root 2, minus square root 2, and minus 1. Now third one is your L over EA for member Ij. E and A is same for all of these members, only length is different. And if you notice here, only two members, which is QT, this one right here and this one here, will have square root 2L. Everything else is going to have L. So we can take L over EA common here and just write it as a multiplier. So this becomes 1, this becomes 1, this also is 1. These two are square root 2, and 1. So now we can multiply these three terms here. So for all of these terms, what we are going to have in common is WL over EA. So this is a common term. Now when we multiply the first term, we get 4. Second term gives us 1. Third term gives us 1. This one right here gives us 2 square root 2. This one also 2 square root 2. And the last one is also 1. So when you combine all this together, your delta V is, so 4 plus 1 5 plus 1 6 plus 1 7. So 7 plus 4 square root 2. And this will be multiplied with WL over EA.